Hello, my name is Valerie Ursua and I'm going to be discussing plate tectonics today. On the agenda we have Alfred Wegener, Marie Tharp, the four plate boundaries, and hotspots. To give a little bit of a background and history about plate tectonics, we will be talking about Alfred Wegener. He created continental drift. He had no mechanism, and he used fossils and other items to prove his theory. He proposed that at some point in the Permian period, all continents were attached together as one supercontinent, suggesting that the continents drifted away from each other and that somehow the plate tectonics were moving. Wegener's main evidence or support he had to prove his theory was the matching of fossils, plants, coal, glaciers, and other items that made a specific pattern. These patterns then showed how the continents were once attached together, which he named Pangaea. This slide has an example of how Pangaea would have looked during this time period, and this was Wegener's theory. However, Alfred Wegener had no way of explaining how the continents drifted or separated from each other, so his theory was dismissed. Marie Tharp also played a major role for plate tectonics. She discovered mountains and ridges in the ocean, and with ocean mapping, she proved the theory of plates moving. She created the first maps of 2/3 of the planet. In order to create these maps, Tharp used sonar soundings of the ocean floor. She hand drew the sonar readings into three-dimensional topography. These drawings revealed that the seafloor was completely different than previously expected. The floor had mountain ranges and ridges across the entire ocean. The ridges in the ocean was more evidence that the seafloor was spreading. Marie Tharp proposed the idea of the seafloor spreading, but was overlooked because she was a woman. However, she was right all along. Here is an example of a seafloor map that Marie Tharp created. She would use black ink and pen to create these maps. On the side of her are the two-dimensional profiles that she would read and use to create these three-dimensional maps. The first type of plate boundary that we are going to be discussing today is convergent boundaries. There are three different plate boundaries. The first one is continental-oceanic, the second one is oceanic-oceanic, and the third one is continental-continental. In this first image right here, we have continental-oceanic convergent boundary. This is when oceanic crust is colliding with continental crust. This right here is the oceanic crust, and on this side is the continental crust. The oceanic crust will subduct underneath the continental crust because it is heavier. Therefore, as it moves underneath, the magma right here will start to rise up and push up towards the continental crust due to the pressure. The slope of the oceanic crust moving together with the continental crust creates a trench, which we can see right here, while the magma pushing up towards the continental crust creates a mountain range with volcanoes, which is right here on top of the continental crust. These plate boundaries are known for earthquakes as well. Some examples of what a continental oceanic boundary has formed are the Andes and Cascade mountain ranges. In this second image right here, we have oceanic-oceanic convergent boundaries. One of the plates subducts underneath the other. Usually the older and colder plate is the one that is heavier, so it is the one that moves underneath a much younger and hotter plate. So for this image, this plate right here is subducting under this newer plate right here. In the same way as continental oceanic boundary, the slope will create a trench, as we can see right here. The magma pushes up to create island arcs or underwater volcanoes. You can see the magma that is rising up here, creating these underwater volcanoes. These plate boundaries are also known for earthquakes, and an example of oceanic plate boundary is the Philippines. The third image right here is continental convergent boundary, also known as collision. This boundary is when a continent collides with another continent. The plate does not subduct because it is too light. This part right here will break off and just melt into the mantle. When this occurs, the pre-existing land is transformed into something else. These boundaries create mountain ranges because there is no magma that is being pushed up under the crust. An example of this boundary is the Himalayan mountains. On this slide, we are going to talk about divergent plate boundaries. There are two different plate boundaries, which is oceanic and continental. Divergent boundaries occur when two plates are moving apart from each other. The spreading of the plates pushes up magma from the mantle, which then hardens and creates new oceanic crust. This right here would be an example of oceanic. Oceanic divergent boundaries can create pillow lavas because of the magma being pushed out into the ocean. An example of this boundary is the mid-ocean ridge, which you can see right there. Here you have the mantle, which is also spreading. The crust is spreading apart, and then there are other sediments being formed. This is an example of continental. For continental divergent boundaries, magma is being pushed up from the mantle, causing the crust to rift or split apart, thus creating a valley or a lake or forming oceans, which you can see right there. An example of this boundary is Iceland, or also this is an example of the African Rift Valley. The third type of plate boundary we will be discussing is transform plate boundaries. This is when one plate slides past another. They move side by side or right to left and left to right. There is no destruction of the crust, and it also does not produce new crust. There are no volcanoes, some mountains, and many earthquakes on transform plate boundaries. One well-known transform plate boundary is the San Andreas Fault. This type of plate boundary we have been discussing with convergent and divergent, which is subduction. And here's another example of what happens is one plate is subducting underneath another plate, which creates a trench, and the magma rises up from the mantle, creating volcanoes or underwater volcanoes. And subduction is basically just sliding underneath another plate. The last thing that we are going to discuss is hotspots, which are completely different from the other plate boundaries we have discussed. Hotspots do not touch plate boundaries. However, it is a place where magma rises from the mantle, affecting the crust above it. These areas are extremely hot and come from deep in the earth. You can see we have a hotspot right here. The magma is rising up to form volcanoes. The hotspot does not move, but the plates can move over them. Some are under continents, while most are located in the ocean. This image is an example of a hotspot located in the ocean, and it is also an example of how Hawaii was formed. An example of a hotspot underneath a continent is Yellowstone National Park, located in California. So that is all for today's presentation. We learned a little bit about the background and history of plate tectonics. We also talked about the four main plate boundaries, and we discussed a little bit about hotspots. Thank you.